So hello everyone. So this is our first topic in General Engineering Enhancement course, College Algebra. Of course, the most basic. So ito yung mga course contents natin for today. So we'll be talking about number system, theory of equation, quadratic equation, cubic equation, binomial expansion or the binomial theorem, exponents and radicals, properties of logarithm, ratio, proportion, and variation. Then, mga worded problems like age problem, mixture, coin, or number problem, the clock problem, work, and rate. And after that, we'll proceed with sequence and progression. Okay? So, first one, the number system. So, we know that the number system is divided into the real numbers and imaginary numbers. So, yung real numbers natin, it is composed of the natural numbers. So, yung mga 1, 2, 3, 4, 5, 6. Kapag naman sinabing whole number, so kasama na yung 0 doon. So, 0, 1, 2, 3, 4, 5, and so on and so forth. Then, yung integers natin, of course, the negative, 0, and the positive numbers. Then, yung rational numbers naman, pag sinabing rational numbers by the name itself, these are numbers that can be expressed as a ratio of two numbers. And irrational number naman, syempre, meron siyang prefix na IR sa unahan niya. So, non-rational number siya. So, it cannot be expressed as a ratio of two numbers. Then, we also have here as surd. So, yung surd natin, so example niya dito, square root of 2, 2 plus square root of 3, cube root of 5. So, ito naman yung mga numbers na cannot be simplified. So, yung mga examples nito is mga radical expressions. Okay? So, we also have an imaginary number. So, it is a complex number that can be written as a real number multiplied by the imaginary unit I, which is defined by its property. I squared is equal to negative 1. So, I squared natin, that's equal to negative 1 daw. So, if we have I raised to 3, that is equal to I multiplied by I squared. But since I squared is equal to negative 1, so this will be I multiplied by negative 1. So, yung I cube pala natin, that is equal to negative I. Now, to compute for I raised to 4, so I raised to 4 can be expressed as I squared raised to 2, but I squared is equal to negative 1. So, negative 1 squared, that is equal to positive 1. So, paano naman if we have, for example, I raised to 23? So, if we want to solve for this imaginary number, so we have to express this as a product of two imaginary numbers. So, I raised to 23 can be I raised to 20 multiplied by I raised to 3. Yung I raised to 20 natin, that is equal to I raised to 4 raised to 5 times I raised to 3. Since yung I raised to 4 natin, that's just 1. So, ito, 1 na lang to. And we have I raised to 3 equal to negative I. So, I raised to 23 natin, that's equal to negative I. Okay? We have here a question about the real number. So, real numbers that cannot be expressed as quotient of two integers, of course, that is irrational number. So, for this problem, we have the number 0.069, 069, 06907. So, anong number daw ito? Is it rational, irrational, surd, or transcendental? So, as you can see, yung number natin dito is a repeating decimal number. So, para ma-check natin if it's irrational or irrational number, so we can simply type in our calculator. So, type natin 0.069, 069, 069. So, hanggang sa magsawa tayo. And then, click nyo yung equal. So, may lalabas dyan na rational number, and that is equal to 23 over 333. So, sagot natin dito is rational. Okay? Third question, it contains irrational roots of numbers. So, this is third. So as we defined earlier, so that is third. So for the fourth question, it is not the root of an algebraic equation with rational coefficient. So we have third, transcendental, radicand, or Lagrange. So ang sagot natin dito is transcendental. So yung mga transcendental natin, examples ito is yung pi, yung Euler number natin, si E. So yun yung mga examples ng transcendental. Next. So, which of the following is a prime number? So, paano nga ba natin masabi if a number is a prime number? So, if all the factors is only 1 in itself. So, prime number yon. Pero kapag meron pa siyang factor other than 1 in itself, so yun naman ay composite number. So, sa mga choices natin dito, we have 15, 17, 39, and 93. So, si 15, meron ba siyang ano ba yung mga factors niya? So, di ba, factor niya is 1, 3, and 5. So, meron pa siyang factor other than 1 and itself. So, hindi siya prime number. Si 39 ba? Ano yung mga factor niya? So, meron siyang 1, 3, 13, and 39. So, hindi rin siya prime number. Si 93, so, check din natin siya. It's divisible by 3 and 7. So, ang sagot lang natin dito is, of course, letter B, si 17. Since yung factor lang niya is 1 and itself, the 17. So, for this problem, solve for I raised to 41 plus I raised to 33 plus I. So, we just have to simplify this expression. So, ra-write lang muna natin siya I raised to 41 plus I raised to 33 plus I. Then, yung I raised to 41, we can express this as I raised to 40 times I plus yung I raised to 33 can be I raised to 32 times I plus I. Since sabi natin kanina, yung I raised to 4 kasi, that is equal to 1. So, ito, cancel natin siya since equal naman yun sa 1. So, we have I plus I plus I. So, hinahanap natin is equal to 3i. Ayun. So next, a diagram where complex numbers are represented in a Cartesian plane, the coordinates of which are the real and imaginary parts of a given number. So ito, guys, that is both A and B. So this diagram is what we call as the Argand diagram, also known as the Gaussian plane. So, sagot natin, both A. Now, let's proceed with the next topic. So, under parent ng number system, greatest common divisor or GCD. So, that is the largest natural number that divides two or more numbers evenly. So, mas familiar tayo dito as GCF, the greatest common factor. The next one is the least common multiple. So, ito naman yung smallest integer exactly divisible by all of a given set of numbers. Then, the least common denominator, of course, is the LCD, smallest integer exactly divisible by all denominators of a given set of fraction. So, we have here an example. So, find the greatest common divisor of 180 and 280. So, list na lang muna natin yung mga factors or divisors nila. So, we have 180 equals so 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 20. What's next? 30. 36, 45, 60, 90, and 180. Okay? Then for 280, we have 1, 2, 4, 5, 7, 10, 14, 20, 28, 40, 56, 70, 140, and 280. So let's look for the common. So common nila, divisor. So merong 10 pareho, but we have a 20 here. So our answer is 20. Okay. So for this problem, we have to find the least common multiple of 180 and 280. So let's list the factors na lang muna. 180 natin, that is equal to 2 times 2 times 5 times 3 times 3. Then we have 280, that is equal to 2 times 2 times 5. 20, that's 2 times 7. Tama ba? 20 times 2, 40 times 7 is 280. Then, kunin natin yung common nila. So, this one is common. So, let's list that. 2 times 2, that's 4 times 5 times, yung mga natira natin is 3 times 3 times 2 times 7. So, 4 times 5 times 3 times 3 times 2 times 7. So, that is equal to 2,520. Yes, so that's our answer. Now, for our next topic, so we have laws of natural numbers. So, let A, B, and C be natural numbers. So, we have closure. So, we have A plus B, or A times B. So, those are natural numbers. We have commutative law. Order does not matter. So, yung A plus B natin, that's just the same as writing B plus A. Or if we have A times B, that is also equal to B times A. For associative law, so grouping doesn't matter. So, A plus quantity B plus C, that's also equal to quantity A plus B plus C. So, kapag multiplication, so ganun din, we have A multiplied by quantity B times C, that's equal to quantity A times B times C. We also have distributive law. So we have A multiplied by B plus C, that's equal to AB plus AC. Or if we have A multiplied by B minus C, that's just simply equal to AB minus AC. Then we have identity law. So for addition, we have A plus 0, that is equal to A. And for multiplication, we have A multiplied by 1, that is equal to itself, equal to A. So for inverse, so for addition, we have A plus negative A, that's equal to 0. For multiplication, we have A multiplied by its reciprocal, and that is equal to 1, provided that A natin is not equal to 0. So we also have laws of equality. So let A, B, and C be natural numbers. We have reflexive property, A is equal to A. Symmetric property, if A is equal to B, then B is equal to A. Transitive property, so if A is equal to B, then A plus or minus C is equal to B plus or minus C. Then, we also have multiplication and division property. So we have, if A is equal to B, then A multiplied by C is equal to B times C. Then also, if we have A equal to B, so then A over C equal to B over C, provided that C is not equal to 0. We also have substitution property. So, of course, if we have A is equal to B, that means we can replace A to B. Cancellation property, so if A plus or minus C is equal to B plus or minus C, then A is equal to B. So that's it. So we have here a question, a basic property which states A plus B equal to B plus A, that is commutative law. So we have the statement A plus B plus C is equal to C plus quantity A plus B illustrates which property of real numbers? So that is, grouping doesn't matter, associative law. So which states the additive inverse property of real numbers? So additive inverse, so that is equal to A plus negative A is equal to 0. The multiplicative inverse of x over 3. So yung multiplicative inverse natin is just simply the reciprocal of that number. So that is equal to 3 over x. Next, the identity element for addition is equal to 0, of course. So if we have A plus 0, that will be equal to A. Next, so we have an axiom here, which axiom is shown by A is equal to B equal to A. So that is symmetric axiom. So next we have the term of a sum may be grouped in any manner without affecting the result. So simply saying, grouping doesn't matter, so that is associative law. If equals are added to equals, the results are equal. So this is an axiom. So take note natin yung mga words na ganito. A mathematical argument that appears to prove something that we know is incorrect. So this is fallacy. Next, a subsidiary result proved in order to simplify the proof of a required theorem, that is lemma. Next, a statement or formula that can be deduced from the axioms of a formal system by recursive application of its rules of inference, that is theorem. We also have a statement that is stipulated to be true for the purpose of constructing a theory, in which theorems may be derived by its rules of inference. So, hindi na lang natin napipili dyan. So, malamang yun na yung sagot. That's axiom. For the theory of equations, we have number of roots of an equation. So, every rational integral equation f of x is equal to 0 of the n degree has exactly n roots. So, for example, we have an equation x cubed plus 3x squared minus 2x plus 1 is equal to 0. So, we have here an exponent of 3. So, this means that this equation has exactly 3 roots. So, example, we have x raised to 5 minus x cubed plus 2x minus 1 is equal to 0. So, yung highest degree niya is 5. So, this means that this equation has 5 roots of equation. So, that's it. Now, for the remainder theorem, if a polynomial f of x is divided by x minus k, the remainder is f of k. For the factor theorem, so if x minus k is a factor of a polynomial, the f of x, then the remainder f of k is equal to 0. So for us to visualize it, let's answer this problem. So the remainder, when 2x raised to 4 minus kx minus 15x squared minus 3x minus 2 is divided by x minus 3, that's equal to 4. So what is the value of k? So by the remainder theorem in the previous slide, so I'll just have to substitute 3 in the equation and equate it by the remainder, which is 4. So we have f of x equal to, let's rewrite the equation, 2x raised to 4 minus kx minus 15x squared minus 3x minus 2, and it's divided by x minus 3, or f of 3, that's 2 times 3 raised to 4 minus k times 3 minus 15 times 3 minus 3 times 3 minus 2, and let's equate this into 4. So we have 2 times 81 minus 3k minus 15 times 9 minus 9 minus 2 is equal to 4. So we have 162 minus 135 minus 11 is equal to 4. Simplifying, we have 3k is equal to 12 or k is equal to 4. So that is the value of k. Now for the next problem, so find the value of k for which x plus 4 is a factor of x cubed plus 2x squared minus 7x plus k is equal to 0. So in order for the x plus 4 to be a factor of this equation, we just only have to substitute this in the equation, then equate to 0. So f of x equal to x cubed plus 2x squared minus 7x plus k. That is x plus 4, so negative 4. Then substitute natin siya. 2 negative 4, 2 minus 7 times negative 4 plus k, and equate natin sa 0. So we have negative 4 cubed, that is equal to negative 64 plus 2 times 16 plus 28 plus k is equal to 0. So we have negative 64 plus 32 plus 28 plus k is equal to 0, and k is equal to 4. Yes. Next problem or next topic. So theory of equations, we have Descartes' rule of signs. So it states that the number of positive real roots of a polynomial f of x is either equal to the number of variation in sign of f of x or less than that number by an even integer. The number of negative real roots naman of a polynomial f of x is either equal to the number of variations in sign of f of negative x or less than that number by an even integer. So to visualize this Descartes' rule of sign, let's answer this problem. So the expression 3x raised to 4 plus x squared plus 7x plus 1 is equal to 0 contains how many imaginary roots? So by Descartes' rule of sign, we just only have to substitute positive x dun sa equation natin and count the number of variation in sign. So dito, pag sinubstitute natin yung positive x, so we have 3x raised to 4 plus x squared plus 7x plus 1 is equal to 0. So, ganun pa rin siya. X squared plus 7x plus 1 is equal to 0. So, ito is positive, 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 positive is equal to 0. So, hindi nagbago yung sign natin. Therefore, no positive real root. Now, let's check for the negative real root. So, let's substitute the negative x. 3 negative x raised to 4 plus negative x squared plus 7 times negative x plus 1 is equal to 0. So, we have 3 times x raised to 4 plus x squared minus 7x plus 1 is equal to 0. So, ito, positive, positive, hindi nagbago. Ito, positive, negative, so we have 1 negative and positive, so we have another variation. So, we have 2 negative real roots. So, we have no real roots, no positive real root, and we have 2 negative real roots, and yung exponent natin ng equation is raised to 4. So, this means na meron pang natitirang ilang imaginary root. Answer natin, 2. So now let's proceed with the quadratic equation. So we have the general form ax squared plus bx plus c is equal to 0. So we have methods of finding the roots. So we can find it by factoring, completing the square, or by the quadratic formula, which is equal to x equal to negative b plus or minus b squared minus 4ac over 2a. So the nature of the roots by discriminant. So if the discriminant b squared minus 4ac is equal to 0, then the roots are real and equal. If b squared minus 4ac is greater than 0 and a perfect square, so the roots are real, rational, and unequal. But if b squared minus 4ac is greater than 0 and not a perfect square, so the roots are equal, are real, irrational and unequal. Then if b squared minus 4ac is less than 0, then the roots are complex numbers. Now for the relationship between roots and coefficients, to find the sum of roots, we have x sub 1 plus x sub 2, that's equal to negative b over a. For the product of roots, that's equal to c over a. For opposite roots, we have x sub 2 is equal to negative x sub 1, b is equal to 0. For the reciprocal roots, that's equal to x sub 1 times x sub 2, that's equal to 1. So we have here a problem about quadratic equation. So the equation whose roots are the reciprocal of the roots of the equation, 2x squared minus 3x minus 5 is equal to 0 is which one of this equation? So first, let's factor the given. 2x squared minus 3x minus 5 is equal to 0. Factor 2x, x. So factor na is 5. Gawin natin 5 and 1. Since yung nasa middle term natin is negative, so this must be negative. This is positive. So, ang factor niya is x1, 5 over 2. x2 natin is negative 1. But we're looking for an equation whose roots are the reciprocal of these roots. So, x1 natin, 2 over 5. x2 natin, reciprocal ng negative 1. That's just the same, negative 1 pa din. So, we have 5x minus 2 multiplied by x plus 1 is equal to 0. So, by FOIL method, so multiply lang natin 5x squared, outer 5x, minus inner 2x minus 2 equal to 0. So, we have 5x squared plus 3x minus 2 is equal to 0. And that is letter B. Next, so find the value of k if 4x squared plus 6x plus k will have equal roots. So, in order for this equation to have equal roots, so dapat siya ay perfect square trinomial. So, k natin, that should be equal to b over a quantity squared. So, yung b natin dito, that is 6 over 4, then squared. So, 6 over 4 can be simplified as 3 over 2. Square natin, that's also equal to 9 over 4. So, two reviewees from PNC solve a quadratic equation in X. One student made a mistake on the coefficient of the linear term and found the roots to be 1 and 2, while the other made a mistake in the constant term and found the roots to be negative 1 and 2. So what was the correct quadratic equation? So let's consider the first student. So the roots are 1 and 2. So that's x minus 1, x minus 2. So by FOIL method, we have x squared, negative 1 times x, negative 2 times x, that's negative 3x plus 2, negative 1 times negative 2. Then, he made a mistake on the coefficient of the linear term, so this is wrong. For the second student, So we have found the roots to be negative 1 and 2. So that is x plus 1 and x minus 2. So by full method, we have x squared. That's x. That's negative 2x. So that's minus x minus 2 is equal to 0. So the constant term here is wrong. So we have x squared minus x plus 2. And that is the correct equation. Now let's proceed with the cubic equation. So the general form is x cubed plus ax squared plus bx plus c is equal to 0. Methods of finding the roots. We have bisynthetic division or a trial and error. The nature of roots by discriminant. We have q cubed plus r squared equal to 0. So all roots are equal, at least 2 being equal. If we have q cubed plus r squared greater than 0, we have one real root, 2 complex conjugate. For less than 0 naman, all roots are real and unequal. So for the relationship between roots and coefficients, we have sum of roots equal to negative a, product of roots negative c, and the sum and product of two roots that's equal to b. So find the sum and product of the roots of the equation x squared plus 3x plus 1. So yung sum of products natin, that's equal to negative b over a. So that's equal to negative 3 over 1 or negative 3. For the product naman, we have c over a. And that's equal to 1 over 1 or equal to 1. So yung nahanap natin is 1 and negative 3. Next, so we have the roots of the equation are negative 1, 2, and 4. So what is the equation? So factors or roots of equation natin, x minus 1, that's x plus 1. Then x minus 2 and x minus 4. So let's just multiply these terms. So we have this one. So just full method, we have x squared. 1 times x, x minus 2x, negative x. 1 times negative 2 is negative 2. Then multiplied by x minus 4. So let's just distribute the x on these three terms. We have x cubed minus x squared minus 2x minus 4x squared plus 4x plus 8. So we have x cubed minus negative x minus 4, we have negative 5x squared. Negative 2x plus 4x, we have 2x. And positive 8 equal to 0. And that is letter A. Now, our next topic is binomial expansion or binomial theorem. Is the expansion of the expression x plus y raised to n. So we have here this one. So if we have x plus y raised to 0, of course, that is equal to 1. Raised to 1, that's simply x plus y. Raised to 2, x squared plus 2xy plus y squared, and so on and so forth. So this is just based on the Pascal's triangle. So a triangular array constructed by summing adjacent elements in preceding rows. So Pascal's triangle contains the values of the binomial coefficient. It is named after the 17th century French mathematician Blaise Pascal. So we have here some important properties. So the number of terms in each expansion is n plus 1. The first and last terms natin is x raised to n and y raised to n respectively. The sum of exponents in every terms is n. The exponent of x decreases by 1 term by term from n to 0. The exponent of y increases by 1 term by term from 0 to n. And lastly, the coefficient of the term equidistant from n's are equal. So coefficient of next term, we have here a formula. C is equal to the coefficient of the previous term multiplied by the exponent of x of the previous term over the exponent of y of the previous term plus 1. We have the general term of the expansion. For a term with y raised to r, so if we are looking for the y rth term, so we have to use the formula n c r x raised to n minus r y raised to r. For the rth term, we have n c r minus 1 x raised to n minus quantity r minus 1 y raised to r minus 1. So for the sum of coefficients, just substitute 1 to every variable, then simplify. For sum of exponents naman, that's just simply equal to n multiplied by n plus 1. So let's find the sixth term in expansion of a plus 2b raised to 8. So in this problem, our n is equal to 8 and our r is equal to 6. Since we're looking for the sixth term of this expansion, we're going to use the formula for the rth term. So for sixth term, we have n c r minus 1 x raised to n minus r minus 1 y raised to r minus 1. Note that this x here is the first term, which is a, yung y natin the second term, and that is 2b. So let's substitute. N natin is 8 c 6 minus 1 a raised to 8 minus 6 minus 1 y natin, that is 2b raised to 6 minus 1. So this is equal to 8 c raised to 5 a raised to 6 minus 1 is 5, 8 minus 5 is 3, then 2b raised to 5. So we have here 8c5 a cubed. 2 raised to 5 is 32 and b raised to 5. So 8c5 times 32, that's equal to 1792 a cubed b raised to 5. Now let's find the term involving x raised to 6 and the expansion of x squared plus 1 over x raised to 12. So since we're looking for the term involving an x raised to 6, we're going to use the first formula, and CR x raised to n minus r y raised to r, and we're looking for r. So n is 12, then CR x natin is the first term, which is the x squared, then raised to 12 minus r. Our y here is the second term, and that's equal to x raised to negative 1. So raised to r. So simplify natin, we have 12cr x raised to 2 times 12 is 24 minus 2r, then x raised to negative r. So 12cr x raised to 24 minus, multiply natin, negative 2r, then negative r, so we have negative 3r. Now we're looking for x raised to 6. So this must be 6. So let's just write it as 24 minus 3r is equal to 6. So 24 minus 3r is equal to 6. So r is equal to 6. 24 minus 6 is 18 divided by 3, that is 6. So I can substitute this back here. So 12 c6 x raised to 6, and 12 c6 is equal to 924. Next problem, what is the sum of the coefficients of the expansion 2x minus 1 raised to 20? So sabi natin kanina, in order to find the sum of the coefficients, just simply substitute 1 in the equation and simplify. So in our given, we have 2x minus 1 raised to 20. So, substitute lang natin yung 1 sa lahat ng x. So, we have 2 minus 1 is 1 raised to 20. That's equal to 1. So, now let's talk about the loss of exponents. So, we have here a raised to 0, that's equal to 1. If we have a raised to negative n, so that's equal to 1 over a raised to n. And kapag baliktad naman, so we have 1 over a raised to negative n. So, iakit lang natin yung a raised to n papunta sa taas para maging positive yung exponent niya. Then, if we have an exponent na fraction, so a raised to 1/2, that is equal to square root of a, and a raised to 1 over m, that is equal to m root of a. Then, product of a raised to n and a raised to m, so just add the exponent, so a raised to m plus n. Then, for the quotient of a raised to n and a raised to m, so you just have to subtract their exponents, a raised to n minus m. Then, for the a raised to n raised to m, that's product lang. So, i-multiply lang natin yung exponent ng dalawa. We have a raised to m n. Then, for distributive or for distribution of exponent, quantity a, b raised to m. So, this is equal to a raised to m, b raised to m. So, same method when dealing with quotient a over b. So, raised to m, that's equal to a raised to m over b raised to m. Now we have properties of radicals. So, radical is an expression of the form nth root of x, which denotes the principal nth root of x. So, the nth root of x is equal to x raised to 1 over n, where n is the index, x is the radicand, and this is the radical sign of symbol. Now, for the loss of exponents, so properties of radicals. So, in terms of fractional exponent, if we have here nth root of x raised to m, so pwede nating ilabas yung m, so equal lang yun. Then, equal siya sa x raised to m over n. So, ito is just a review of the properties of radicals. So, for this problem, if 3 raised to x plus 1 minus 3 raised to x minus 1 is equal to 72, then x is what? So, actually, for this problem, we can just use the choices and see which of them will satisfy the equation. So, for example, let's see letter A, 2. 3 raised to 2 plus 1, so that's gonna be 3 raised to 3, 27 minus 3 raised to 2 minus 1, that's 3, so not 2. If 4, so 3 raised to 4 plus 1, that's 3 raised to 5, minus 3 raised to 3, no, so that's not 72 also. If 3 raised to 3 plus 1, that's going to be 3 raised to 4, 81, minus 3 raised to 3 minus 1, 3 squared, so 9. 81 minus 9 is 72. So, by just substituting the choices and the problem, so we can find out the answer. But if you want to solve it algebraically, so solve natin siya ngayon. So, let's just rewrite it first. 3 raised to x plus 1 minus 3 raised to x minus 1 equal to 72. So, rules of exponent, we can separate this as 3 raised to x times 3 minus 3 raised to x times 3 raised to negative 1 and 72. So, we can factor out the 3 raised to x. 3 minus 3 raised to negative 1 equal to 72. And 3 raised to x. 3 raised to negative 1 is also equal to 1/3. So we have 3 raised to x. 3 minus 1/3 is 8/3. So we can simplify this as 3 raised to x equal to 72 divided by 8, 9 times 3, 27. And 27 can be expressed as 3 raised to 3. Therefore, x is equal to 3. Ayun. Next, so may naligaw na problem. If the polynomial x cubed plus 4x squared minus 3x plus 8 is divided by x minus 5, so what will be the remainder? So let's just substitute the given. We have x cubed plus 4x squared minus 3x plus 8. So substitute the 5 cubed plus 4 5 squared minus 3 5 plus 8, and this is gonna be 125 plus 25 times 4, that's 100, minus 15 plus 8, and that's equal to 225 minus that's 218. Yes, it's 218. Next, so if 8 raised to x is equal to 3, find the value of 2 raised to 6x. So again, we can just use the choices here to find the answer, or pwede rin tayong gumamit ng shift solve. So 8 raised to x equal to 3, or pwede rin tayong mag-loan para ma-solve natin. Loan of 8, diba? Pwede tayong loan of 8 raised to x equal to loan of 3. Then, bababa natin yung x. Kakaroon tayo ng x loan of 8 is equal to loan of 3. So, x equal to loan of 3 over loan of 8. Then, ito yung substitute natin sa x dito. Tapos, may makuha tayong sagot. But, if you want to apply the rules of exponent, so, kailangan natin i-express yung mga given na madali siyang masosolve. So, I will consider this one, 8 raised to x equal to 3. So, yung 8 natin, we can express this as 2 raised to 3x. That's equal to 3. And as you can see, yung 2 raised to 6x po natin, pwede natin siyang i-express as 2 raised to 3x raised to 2. Tama ba? Kasi, diba, 3x times 2, that's 6x also. So, if 2 raised to 3x is equal to 3, so that means this one is equal to 3 squared, or simply 9. And that is our answer. Ayun. So, kung saan kayo nadadalian, syempre, yun yung pipiliin nyo. Now, let's proceed with logarithm. So, the logarithm of any number n to a given base a is the index x to which the base must be raised, make it equal to the given number. So, we have equation. This is the logarithmic form. X is equal to logarithm of n to the base a. Exponential form naman natin is a raised to x is equal to n, where x is the logarithm of n to the base a. Now we have some types of logarithm, the natural logarithm or Naperian logarithm using base e. So we have some properties of natural logarithm. If we have product of xy, ln of xy, that's equal to ln of x plus ln of y. Ln of x over y, that's equal to ln of x minus ln of y. Ln of x raised to n, that's equal to n multiplied by ln of x. Then, we also have ln of e, that's equal to 1. Ln of e raised to n, that's equal to n. And e raised to ln of x is equal to x. Then, we also have common logarithm or Briggshian logarithm using the base 10. So this rule is just the same with the first the properties of the natural logarithm. Naging logarithm lang yung ating term dito. And we have here a note, so negative numbers have no real logarithm. Now for this problem, given logarithm of 6 plus x logarithm of 4 is equal to log of 4 plus log of 32 plus 4 raised to x to find the value of x. So we can just use shift solve in solving these, or just substitute the choices, then see which of these will satisfy the given equation, or use the properties of logarithm to solve this problem. So, and that is what I'm gonna do here. So, I will write the equation is equal to logarithm of 4 plus logarithm of 32 plus 4 raised to x. So, properties of logarithm, if we have plus here, we can combine them as product. So, logarithm of 6 times this one. So, yung x natin, nakit natin sa 4. Then, sa kabilang side, we have logarithm of 4 times 32 plus 4 raised to x. Since both sides may logarithm, pwede natin sila i-disregard. So, we have 6 times 4 raised to x is equal to 4 times 32 plus 4 times 4 raised to x. Lipat natin yung 4 times 4 raised to x sa kabilang side. So, we have 6 times 4 raised to x minus 4 times 4 raised to x. That's equal to 128. Factor natin yung 4 raised to x. We have 6 minus 4 is equal to 128. That is 4 raised to x times 2 is equal to 128. 4 raised to x is equal to 64. And 64 is equal to 4 raised to 3. Therefore, x is equal to 3.